Swayam Prabha. Digital India. Educated India.
Hello all, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are in module number 3, lecture number 23, where we are covering orthographic projections. In the last class, we have learned about first quadrant projections and third quadrant projections. In these first and third quadrant projections, what we have seen, after projection onto the planes, we will get a front view, top view will be below that, from right side if we are trying to look at, the projection will be on the left hand side. So, right side view. If we are observing something from left hand side and projection, if we can get it, that will be left side view on the right hand side. This is the standard convention what we follow for first quadrant systems. In case of third quadrant systems, what we are going to get is a front view. Let us draw it here. A front view, top view will be on top, and perhaps right side view on the right hand side, left side view will be on the left hand side. This is the way we will get for third quadrant systems. In case of first quadrant system, the front view, after folding it from top view comes at bottom, and if we are looking from left hand side, the view comes onto the projection onto this opaque plane of left hand side to the right side, and if we are looking from right hand side, the projection onto the opaque plane comes at left side. This is the way we go ahead, and most of the cases, at least for Indian standards and also for our engineering drawing course, we extensively follow this first quadrant system. So, let us learn more about this first quadrant system. Let us look at this picture. In the first angle or first quadrant kind of system, there is a tapered cylinder having such dimensions. If we are observing from this direction, because this is also a transparent plane through which what we are trying to look at, and this one also another transparent plane. Usually the maximum dimensions available in that direction we try to look at. So, if that is the case, if we are observing from this direction, the projection of this tapered cylinder comes as a trapezium on the other plane, because this is the first one what we are going to observe. So, let us call that one front view. If we are looking from top, again it looks like trapezium. The same symmetric object comes from this view and also from top view. If we are looking from this view, it looks like a circle followed by another big circle. So, on the plane it looks like a circle followed by circle, because we are looking at inclined direction, it might looks like ellipse, but we have to flip or fold this page. Once we fold that, it forms complete circle on that plane. So, if we are drawing this one for this entire object, the front view will be that, and then left side towards right direction we are trying to look at. So, the view followed by these lines, in between that we get a bigger circle which will be visible. Similarly, we are looking in this direction. So, based on these lines we will get one more circle concentric with that, both are visible. Now, top view, if we are looking from that direction, so it projects onto this bottom plane and we are folding it to open it. Then this line and the bottom one coincides. So, there similarly this line, the bottom one coincides and we are looking in that direction, again we see a trapezium of same size. So, this is front view, top view, left to right, left side view. This is the way we construct a picture. So, doing that, the front view object this is the front view object, trapezium. This is the left side view of that object, and our drawing terminology goes in this way. Because it is a cylindrical object, we usually show this center of axis, that is passing from that point, comes from that point. If this is the complete circle, this line pass through that. So, the same line we are showing it here. Second, because this is a circle, on the left side view, a circle and another circle, because this is a cylindrical object having circles. So, again dash dot lines we show to represent that it is a cylindrical object. If we are looking at that in the third angle projection systems, the same cylindrical object in the third quadrant we are placing. So, the planes on which it is projected is this, the planes on which this will be projected is this one projected there, that one projected there. So, if we are flipping that entire plane, it comes to this plane. By folding it, after project onto this plane, then fold it in this direction, rotate it, so that the view what we will get is circle. Similarly, we are looking in the third angle projection. So, the projected one will be this one. This is the way we get the views, required views. In third angle projection system, it is quite common to show these dimensions next to the object by these symbols, because it is a projected one. So, some diameter, another diameter, perhaps length of the object 2.2 d, and usually we show that for the front view. The maximum dimensions we are supposed to show it on the front view, and the remaining leftover dimensions will be distributed on the top view, then after side view. Now, we will look at methods involved on these projections. Any projection we divide into two methods. One is by natural method, other one is glass box method. In case of natural method, what we do is we keep the object as an observer, we walk around that object by looking at that object how it really looks like. The other way is more like you keep the object, slowly rotate it by 90 degrees, either clockwise, anti-clockwise kind of directions, or perhaps from top to bottom 90 degrees or bottom to top 90 degrees. This is the way also we can rotate the object and look at the views. If we are doing that, first keep an object, fix the observer, rotate the object, the views whatever we are going to get, that is what we call natural method. In the glass box method, we construct an imaginary box around this object. Some of them are transparent planes, some of them are opaque planes. Walk around that transparent planes so that the views whatever we get, that what we call glass box method. So, let us look at an object. Here the object is something like in L shape, a block in L shape. And we would like to say this one as the front view. So, you are the person who is looking at the monitor and the object is slightly inclined with you. The easy thing is rotate this object by certain angle in that direction, so that it will be perpendicular to your view direction, in that direction, into that plane direction. So, here if we are rotating that object by that certain angle, this one we will be in a position to view, that one we will be in a position to view. So, rotate that object so that it comes out to be in that shape in the natural method. This is what we call front view of that object. Similarly, for top view object, what we have to do is, this is the object what we are trying to see, and what we want to make is this one front view. So, rotate that in that direction. So, by doing that, we will again get that normal to or perhaps into the plane of that paper. Then whatever the thing we are going to observe, that we call top view. For example, if we are rotating this object in that way, we are going to get this one as the dimension here for the top view. This one, because we are making normal, this entire object comes at that level towards our direction. Similarly, by rotating that in that direction, normal to the plane, we will get right side view. This is what we call natural method. Observer is always be fixed, object will be rotated in such a way that it will be in the view of the observer, and whatever the view we get, that we call this natural method. The other method is called glass box method. This glass box method is to deal with our transparent planes, opaque planes and their projections. So, all the time we are trying to construct this glass box method where there are transparent planes. So, front view, the observer is in this direction. As of now, he is looking in that direction. Whatever the shape he is observing, that let us call front view. This one is the front view projection. So, if you are going to have it, the complete one projection, what he is going to see, that will be of this shape. This is what we call front view. Then to look at top view, he has to go observe that from top side, whatever this projection he is going to get, onto that plane, as this we call as top view. And again for the right side view, he has to come to that direction, look on that plane, whatever it is projected, he is going to get. That is what we call right side view. So, in glass box method, we construct these views, project it onto the planes, then fold them or perhaps rotate them, so that different views we will get. For example, let us look at this one. For the same object, the front view after projection, we might be getting this one. This remains fixed plane. Now, the observer looks from there. So, first of all he will get this one as the object for the right side view. Now, rotate this entire plane by 90 degrees. So, if we are rotating that, we get this view. Similarly, for the object onto that plane, we may be getting this one as the top view. This plane, rotate it 90 degrees. So, once we unfold that, so this is the object on that plane, what we get, this one, that one what we call this top view. Similarly, if we are projecting onto that plane, back side opaque plane, and rotate that, we will get again another view. The back side also we have that also we can unfold it, so that it comes to that level. So, you can think of a box consists of many latch kind of events. So, this plane is always fixed, which we call front view. Now, there is a latch here and there. Similarly, one more thing here, there. Similarly, here, there, and there, there, and there, and there. Now, once it is done, on that box, we open it in such a way that this part comes to top, so that the front view will be there. Let us name it like A plane, B plane, C plane, the back side of is D plane, the bottom one is E plane, the back side of that is F plane. Now, when we are unfolding it, the A plane will be there, the B plane comes on top, the C plane comes at this level, the D plane opens like a box in that way, F plane on the back side, twice we are going to unfold it, so that it comes in this direction F, and the leftover E plane comes at that level. This is the way we unfold this box and their projections. After unfolding all these things, if we are naming it, the front view will be at middle, and supported by that we will have a bottom view, a top view, this is for third angle projection system, because front view, top view on top, right view on the right side and bottom view is on the bottom side. Left view will be on the left side and rear view on the right side. So, based on the third quadrant system, if we are trying to make it and using glass door kind of box method, unopening that, unfolding these things, this is the way we get. And maximum dimensions supposed to be visible on the front view and remaining dimensions will be pushed onto other directions like side views, bottom views, top views and so on. So, the first preference always be front view, then the rest of the dimensions supposed to be conveyed by top view and the remaining views supposed to be taken care by side views. So, let us look at for an object by taking an example. This is the object what we would like to construct the views. Let us go step by step. The first one is, maybe it is easy to construct a glass door kind of thing. Then if we are trying to project onto this glass doors box method, this entire thing projects onto these views. Then unfold this box. So, the front view comes at this level, the top view comes there, the right side view comes at this level, the left side view comes at that level and the back side view comes at this level. So, if we are rearranging all this thing on the drawing sheet using glass box method, projections turns out to be in this way on the drawing sheet. In the next class, we will learn more about other projection methods. Thank you very much.